or eat. Okay, so these are for lines, but you can also talk about the slope or rates of change for any function. How we do that is we talk about the secant line first. Your secant line is a line that intersects a graph at 2 points. If you were to pick 2 points on something that is not a line, right? This is a curve, not a line. So if you were to pick 2 points on a curve and draw a line that connects them, the secant line is that line that goes through those 2 points. If we find the slope of that line, we have found the average rate of change throughout that curve. That no matter what's been happening curvy-wise here, if we're talking about this point, this first point, to this second point right here, the average rate of change is the slope that has happened between those 2 points. No matter how curvy it's happened in between, no matter if it like did up or down or something like that, this is what ended up being the average rate of change during that time. When we're talking about things like calculus, so all the way to calculus that you're going to be learning in your 11th, maybe 12th grade year, calculus, one of the things we talk about is a derivative. And long story short, a derivative represents the tangent line of a curve. Very oversimplified, but that's kind of the main idea, is that we're trying to find a tangent line of a curve when we're finding derivatives, the equation of the tangent line, depending on where you are on the curve. So what we have here is a tangent line, and what happens with this secant line is we try and bring those points closer and closer and closer and closer and closer together, and the closer we bring them, we eventually get to the point where those points are overlapping. This is how we find the derivative, is that we're finding what happens as those points get closer and closer together, and then you end up using that information in order to find the derivative of a function. So that's something, this is intersects at 1 point. That's something to keep in mind, that things like this are applicable now all the way to calculus, which you're going to be learning a little ways down the line. So let's talk about finding your average rate of change using this idea of a secant line connecting 2 dots. The average rate of change, here we go. Are you ready? Get your pencils out. For a function, f of x, the average rate of change on the interval x1, x2. So this is an interval, not a point. So between 2 x values, this interval is the slope of the secant line through x1 and x2. So the average rate of change on an interval is really just the slope between those 2 points. And that is, and then here's your formula. F of x sub 1 minus f of x sub 2 all over x sub 1 minus x sub 2. It's your slope, your change in your y values over your change in your x values. Okay, so we're going to use this, and you're going to see why. We're going to use this for our later problems in the fact that, like, we're normally told, what's the average rate of change between these 2 x values? Well, you need to use those 2 x values to find the 2 y values, and then once you have the 2 y values, then you can find your rate of change. So it's just kind of further enforcing the idea of the process that you have to take in order to find your average rate of change. That's why we kept it as f of x sub 1. So there you go. Let us go ahead and calculate the average rate of change. Last page. Find the average rate of change of this function. I've gone ahead and included a graph of the function. And so we're going to use that graph in order to find our first value, but then I'm going to show you how we can also just do this algebraically if we didn't have a graph, and we're going to do that with B. So first, let's just grab this for A. If we want to find the average rate of change, I would recommend when you see something like a term like this, if there's a formula to go with it, write your formula down. Your formula is f of x sub 1 minus f of x sub 2 all over x sub 1 minus x sub 2. Your order here does matter. If you put x sub 1 first up here, you have to put x sub 1 down here first as well. If you did f of x sub 2 minus f of x sub 1, then on the denominator, you would also have to have x sub 2 first. It's just like your slope, okay? So what is f of, between 0 and 2, f of 0 minus f of 2 over 0 minus 2? F of 0, if we go to an x value of 0, f of 0 is 3. What is f of 2? F of 2 is 5. And this will be over 0 minus 2. 2, 5. This results in negative 2 over negative 2. In other words, positive 1. Your average rate of change on the interval from 0 to 2 is 1. And you can see that. You can connect those two dots. You can draw the line. And you're like, oh, the slope of that line is 1. Fantastic. I would like for you, no, we're going to do this together. From 2 to 4. So we want to do f of 2 minus f of 4 over 2 minus 4. Not looking at the graph, f of 2 would be 2 squared, which is 4, times a half, which is 2, plus 3, which is 5. F of 2 is 5. F of 4, plugging in 4 for x. 4 squared is 16, times a half is 8, plus 3 is 11. That's all you got to do. Plug in those x values and then find the y value that goes with it. That is negative 6 over negative 2, which is positive 3. So between 2 and 4, your average rate of change is 3. It makes sense. The curve that you're covering with these 2 points is a more steep part of your curve, as opposed to earlier, you're talking about a less steep part of your curve. And your average rate of change shows that difference, that in this range, you have a less steep curve, which means you've got a slope of 1, versus later on, you've got a much more steep curve. So it has an average rate of change of 3, which is significantly larger than 1, 3 times larger. Okay. So here's how the general idea of what we're talking about with an average rate of change. Here is typically a way that you would be asked it. We're going to look at it in a more of a 9th grade way, and then we're going to look at it in a more of an IB way. This is a way that's very similar to IB type questions. And we're going to use our calculator to find it. So we're going to find the average rate of change. I'm going to write down my formula first. We're going to do f of x sub 1 minus f of x sub 2 over x sub 1 minus x sub 2. I could also do all of my mini calculations to the side and then plug in my final values at the end. So I could first say, hey, x sub 1 equals 8. F of x sub 1 equals f of 8, which is 2 times the cubed root of 8 minus 3 times 8. Cubed root of 8 is 2. 2 times 2 is 4. 4 minus 24 is negative 20. Go ahead and tell me when x sub 2 equals 27, what is f of 27? The cubed root of 27 is 3. 3 times 2 is 6. 27 times 3 is 60 plus 21, so minus 81. Yeah. 6 minus 81 is negative 75. Okay, now I've got all the values that I need. F of x sub 1, f of x sub 2, x sub 1, and x sub 2. Those are all the values that I need. So now I can just plug them into my formula. Go ahead and plug them in and tell me what you get. Negative 20 plus 75, subtracting a negative, over 8 minus 27 is going to be 55 over negative 19. That approximates to negative 2.90. It's 895, and to 2 decimal places means that 89 would come up to a 90, and you would have to keep both the 9 and the 0 in order to be accurate with that. A little rounding practice.